I start recording, and on previous lesson we consider such new type as array. We discuss how to declare an array, how to operate with array, how to get access to the array elements, how to perform some actions with array elements. We consider some simple algorithms with arrays. Today, I want to consider with you the relation between array and a pointer. That's why I switched to another presentation about pointers. And first of all, let's recall that any information object, any variable, any constant that we use in the program, these information objects are stored in computer memory. When you declare a variable, you should remember that this variable occupies several cells in computer memory. The number of these cells depends on the type of the object. For example, variables of the type char requires 1 byte, variables of the type int requires 4 bytes for storing, and so on. You don't need to remember this number of bytes because there is a special operation sizeof that allows us to compute how many bytes required for storing particular data type or variable. You can call the operation sizeof and it returns the number of bytes. Let's do it. Let me show you the example. For example, I declare integer variable a and double variable x. And let's output the size of integer type, or I can call size of a. I can call the function size of, and the argument, it can be the name of the variable, or it can be the data type. Result will be the same. I can use the name of the data type as a parameter, or I can use the name of the variable. Let's run this program, and we should see 4, 4, and 8. 4 bytes for int and 8 bytes for double. Okay, this is completely the same example that I show you in Visual Studio. But let's consider it in details. All the cells in computer memory are numbered successively with integer numbers starting from 0, and the number of cell is called its address. If an information object is stored in one cell, the number of this cell is considered as the address of this variable. If the variable occupies several cells, like int, double float, in this case, we consider the least number as the address of the variable. So on this diagram, you should see some explanation. Suppose that this cell is the first and the number of this cell is address. So this cell has the number address +1, address +2, address +3. And in this case, the variable a that occupies 4 cell has the address a there, this address, the number of the first cell. How we can get this address? There is a special operation in C++. This operation is denoted as ampersand and is used to get the address of particular variable. For example, if var is identifier of the variable, then ampersand var is the address of the variable in the computer memory. This address is also called a pointer. Well, this is just synonyms, address and a pointer. Every variable has address, and this address is also called pointer. We can print this address using cout statement, but pay attention that this address actually is just an integer number, but it's printed in some special notation, so-called hexadecimal notation. Let's do it. Let me output to the screen address of the variable a. To do it, I should apply the operation of getting the address, the ampersand. After that, we will see on the screen some number that corresponds to the number of the first cell that the variable a occupies. The same I can do for the variable x, address of x. Let's run this program, and we will see on the screen some numbers that are written in a special form that is called hexadecimal form. Again, actually is just integer numbers like 1, 2, 3, 4, 5, 100, 1000, and so on. But these numbers are written in a special notation. But it's no more than just an integer number. Okay, come back to the presentation. Well, actually, this slide shows you the example that I already showed you in Visual Studio. Now, what is a pointer? For efficient work with addresses in Visual Studio, C++ has a special data type that's called pointer. The set of values of this data type is a set of addresses of particular variables in computer memory. For example, what is a set of possible values for integer numbers for the data type int? It's just integer numbers. -1, 0, 1, 2, 3, -4, and so on. What is the set of possible values for pointer? The set of possible values for pointer is addresses in computer memory. How to declare a pointer? Here you may see the general form of pointer declaration. Data type is just the name of the data type. This is identifier, and the star written before identifier, it's special, it's a feature of a pointer declaration. When you declare just int a, it's an integer variable. But if you declare int star a, it will be a pointer. So come back to Visual Studio. A is a pointer, but if you write star in a declarative statement, it means that P will be a pointer. You will see that this sign star has different meaning. It depends on the place where you use it. If you will use star in computational statement, it will be multiplication, A times B. But if you will use star in declarative statement, it will be, the meaning of this star is a declaration of a pointer. Now, P will be a variable that can store the addresses of another variables of integer type. I can assign to this variable the address of another integer variable. This example is written here. Now I repeat it in Visual Studio. I just repeat this example. Suppose that A is an integer variable with a value 0. P is a pointer. And after that, I can write something like this. P equals to %A. It means that I get address of the variable A, and after that, I assign this address to the pointer P. Now, I can say that P points to A. P store the address of the variable A. And I can get access to the variable A using pointer P. Well, I skipped this slide and we consider this one. C language contains a special operation that again denotes with a star. This operation is called operation of indirect addressing applied to pointer. Using this operation, I can get access to a variable A not directly using the name of the variable, but indirectly. using pointer. Here you may see the example. Suppose that I declare a variable a with the initial value 12, the variable b, the variable c with initial value 15, and let me declare a pointer that points to a. Pointer p, sorry, not a, of course, c. This assignment means that the pointer p points to c. And after that, I can get access to the variable c using this pointer, like this. If I write operation star and p in some computational statement, it means that I get access to the variable c, like usual case. Okay, let's do the same in Visual Studio. Suppose that I declare variable a with value 0. Let's output the value of the variable a to the screen. We will see 0, of course. After that, let me assign one. I assign 1 to the variable a using indirect addressing, operation star and p. And after that, if I try to output the variable a to the screen, I will see 0. Sorry, of course, not 0, 1, because I changed the value of the variable. The first value will be 0, and the next value will be 1. I don't have access to the variable a directly. I never write operation something like a equals to something. I change the value of the variable a using pointer. From the first point of view, this operation maybe will seem strange for you. Why we should use pointers instead of the variables? Because I can change the value of the variable using its identifier, but not a pointer. Why we should use pointers? The answer is that the pointers are very closely related with arrays. In C, the name of the variable, the name of the array without square brackets is considered as a pointer. Pointer which points to the beginning of the memory that are allocated to the array. So it contains the initial address of the array. So if I declare the array mass with 4 integer numbers, the identifier mass will be the pointer of the type integer, and this pointer will point to the first element of the array. And if I try to get access indirectly, if I write star mass, in this case, the value of the element will be the value of the first element of the array, mass with index 0. And if I apply operation ampersand mass 0, I will get address of the first element, and it will be the same as mass. Let's do the same. Let's do it in Visual Studio. Suppose that I declare an integer array with 4 elements. I assign the values to this array as 1, 2, 3, 4. Let's output to the screen. The value mass. Let's recall again that the name of the array without square brackets is considered as a pointer. And we will see on the screen the address. Some integer number written in hexadecimal form. Well, if I output to the screen the element mass with index 0, I will see the element that is written in the first cell of the array, especially 1 in our case. Mass 0 equals to 1. But if I try to get access, to get address of this element using the operation ampersand, I will see the same value as mass. Let's check it. These two addresses will be completely the same. Mass and address of mass 0, because it's just the same number. Okay, what happens if I try to get access to the element with index 1? We will see another integer number, but let's compare it. Let's remember that the number of bytes required for storing integer numbers is 4. This address is some digits, and the last 2 digits are 80. If we consider the next address of the next cell, it will be the address of this one plus 4. And it will be 84. The address of the next cell, it will be 88, and so on. Because these cells occupies the continuous part of the memory. Also, I can apply the operation plus addition to pointers. If I add some number to a pointer, it means that we don't add the number 2 to the address of the variable. but we add 2 units of memory of the type int. So it means that we move pointer to the cell number 2. We move pointer to the right on 2 positions when I write mass plus 2. And from this point of view, these 2 forms of getting the access to the array elements are equivalent. Mass n and star mass plus n. This is a usual form, and we will use it in 99% cases. But this form is equivalent to this one, mass plus n and star. Again, let's show you this example in Visual Studio. Let's output to the screen not mass, but mass plus 1 and mass plus 2. Let's see the result. This is the address of the first cell. This is the address of the second cell, plus 4. And this is address of the third cell, again plus 4. If this array will be not integer but character, the data type char requires 1 byte for storing, or it's better to convert it to integer. Yeah, we will see these numbers in integer, and these numbers will be 12, 13, 14, and so on. Plus 1, plus 1, plus 1. If I convert these numbers for int, we also see their integer numbers. Well, and the last thing that I want to say for you today, maybe is the most important thing, how to create an array of variable size. We will use this property that the name of the array can be considered as a pointer, because the pointer also can be considered as name of the array. Suppose that I declare a pointer p. After that, I can write the assignment operation like this: p equals to mass. It means that now p points to the array mass, and I can get access to the array mass using a pointer p. Let's do it. And let me output to the screen here p with index 0, p with index 1, p with index 2, and so on. And we will see on the screen 1, 2, 3, the elements that are stored in this array. But also, I can allocate the memory for the variable p, for the array p manually. Again, suppose that I create here a variable size, for example, with the value 10, And if I write something like this, new int size, it means that I allocate the memory using operator new for the data type int and for size elements. The number of the elements that can be allocated using operator new can be variable. Here in declaration of variable, I cannot use a variable. Here I must use a constant. That's why I cannot change the size of the array in the course of program execution. I can change it only if I recompile my program. But in this case, I can change the size. Even I can write here the output statement. For example, input the size, the in size, and after that allocate the memory for the array of the size element. Here the size is I inputted from the keyboard. And after that, I can operate with array using pointer p. For example, I can write a loop for I equals to 0, I smaller than size, I plus plus, and let's assign some numbers to this array. P with index I equals to, for example, I plus 1 in square, I plus 1 times I plus 1. And after that, I can output this array to the screen. Well, so I allocate the memory for the array, I assign the values, I output these values to the screen, but in the end of the program where I finish my work with this array, I should deallocate the memory. I should release it manually using operator delete. Delete P, I delete the memory that I allocate for the array. And if you allocate more than one element, you should write delete with brackets. Let's run this program and let's check that it works correctly. For example, the size is 8, and we will see on the screen the squares of first 8 elements. If I input the size, for example, 20, I will see on the screen the squares of first 20 integer numbers. Again, I repeated that in this case, the size of the array is changed dynamically. And this array is also called dynamic array. I can do it because the name of the array can be considered as a pointer and vice versa. the pointer can be considered as the name of the array. Well, that's all that I want to consider with you during this lesson. Next week, we discuss about some algorithms with arrays. Maybe we consider how to find the largest and the smallest values, how to sort the array in decreasing or increasing, by decreasing or by decreasing, or maybe some other algorithms. So the next week, algorithms with arrays. I stop sharing my screen and I stopped recording.